New images captured by the Gemini North Telescope in Hawaii have provided compelling confirmation that the interstellar comet known as 3I/Atlas has become both brighter and noticeably greener following its close flyby of the Sun in late October. This change marks a significant escalation in the comet's activity and offers astronomers a rare opportunity to observe how an object formed outside our solar system responds when subjected to intense solar radiation. As 3I/Atlas now races toward its closest approach to Earth, expected within the coming days, scientists are closely monitoring it for potential outbursts that could reveal even more about its composition and origin. The observations were made on November 26th using the Gemini North Telescope, which sits atop the dormant Mauna Kea volcano, one of the world's premier sites for astronomical research due to its high altitude, stable atmosphere, and minimal light pollution. At the time of the observations, 3I/Atlas was undergoing one of its most active phases since its discovery. The comet had recently emerged from its perihelion passage, the point in its orbit where it came closest to the Sun, and the intense heat it experienced during that encounter appears to have dramatically altered its appearance and behavior. As the Sun's radiation heated the comet's surface, frozen materials that had likely remained unchanged for billions of years began to sublimate, transforming directly from solid ice into gas. This process released vast quantities of gas and dust into surrounding space, forming a bright, diffuse cloud known as a coma around the comet's nucleus. At the same time, solar wind and radiation pressure stretched this material outward, creating a long, luminous tail that now trails behind the comet as it hurtles through the inner solar system. To fully understand the nature of these changes, astronomers observed 3I/Atlas through 4 different optical filters: blue, red, orange, and green, allowing them to separate and analyze the various wavelengths of light emitted by the comet. The results revealed a subtle but unmistakable greenish glow in the coma, a feature that had not been present in earlier observations. This new coloration suggests that the comet is now releasing different gases than it was just a few months ago, indicating a shift in its chemical activity as deeper layers of material are exposed. While the sudden appearance of green light might spark imaginative speculation, scientists are quick to point out that there is nothing unusual or artificial about the phenomenon. The green glow is most likely produced by diatomic carbon, a molecule composed of 2 carbon atoms, commonly abbreviated as C2. When this molecule is energized by ultraviolet sunlight, it emits light in the green portion of the visible spectrum. According to a statement from the National Science Foundation's NOR lab, which operates the Gemini Observatory, the presence of C2 is a well-known feature of active comets and has been observed many times within our own solar system. Indeed, several recent comets have displayed similar green hues when they became active near the Sun. Among them are the periodically eruptive comet 12P/Ponsbrooks, nicknamed the Mother of Dragons due to its dramatic outbursts, and the more recently discovered Comet C/2025F2 Swan. In these cases, the green glow served as a visible indicator of chemical reactions taking place within the coma as solar heat unlocked volatile compounds trapped within the comet's icy nucleus. What makes 3I/Atlas especially intriguing, however, is its interstellar origin. Unlike most comets, which formed within the early solar system and orbit the Sun repeatedly, 3I/Atlas originated around another star entirely and is merely passing through our cosmic neighborhood. This makes it only the 3rd confirmed interstellar object ever observed, following Oumuamua in 2017 and 2I/Borisov in 2019. Each of these visitors has behaved differently, offering unique insights into planetary systems beyond our own. Earlier observations of 3I/Atlas, made in late August by the Gemini South Telescope in Chile, painted a very different picture. At that time, months before its close solar encounter, the comet appeared distinctly redder in color. This reddish tint is typically associated with dust-rich material reflecting sunlight rather than gas emission. The shift from a dust-dominated appearance to one featuring strong gas emissions suggests that the comet is now releasing fresh molecules that were previously buried beneath its surface. This transformation provides valuable clues about the internal structure and composition of 3I/Atlas. The comet's outer layers may have been depleted or processed during its long journey through interstellar space, leaving more pristine material locked away beneath the surface. As solar heat penetrates deeper into the nucleus, it activates these untouched reservoirs, releasing gases that have never before been exposed to a star like our Sun. Studying these emissions allows scientists to compare the chemistry of distant planetary systems with that of our own, potentially revealing whether the building blocks of planets and life are common throughout the galaxy. The increasing brightness of 3I/Atlas also raises the possibility of sudden outbursts, in which pockets of volatile material rapidly erupt from the nucleus. Such events are not uncommon in comets, particularly after perihelion, when internal pressure from sublimating ice can fracture surface layers. If an outburst occurs, it could temporarily make the comet significantly brighter and provide an even clearer look at its composition through spectroscopic analysis. As the comet approaches Earth, astronomers are taking advantage of this rare alignment to gather as much data as possible. Although 3I/Atlas poses no threat to our planet, its proximity allows telescopes to resolve fine details in the coma and tail that would otherwise be impossible to observe. Each new observation adds to a growing dataset that will be analyzed for years to come, long after the comet has left the solar system behind. The study of 3I/Atlas underscores the importance of global astronomical infrastructure and international collaboration. Facilities like Gemini North and South, operated by NOIR Lab, enable scientists to track transient objects across both hemispheres, ensuring continuous coverage as they move across the sky. These observatories also demonstrate how modern astronomy relies on rapid response and adaptive observation strategies to capture fleeting phenomena. Ultimately, the greening and brightening of 3I/Atlas is more than a visual curiosity. It represents a moment when material forged around another star is briefly illuminated, transformed, and revealed by our own Sunday. For a short time, humanity is able to study a fragment of a distant planetary system as it reacts to conditions it may never have encountered before. Each photon captured by telescopes like Gemini carries information about the chemical diversity of the universe and our place within it. As 3I/Atlas continues on its hyperbolic trajectory, it will soon fade from view, returning to the cold darkness between the stars. Yet the data gathered during its passage will continue to inform scientific models and inspire new questions about how common such interstellar wanderers may be and what secrets they carry within their ancient ice. In this sense, the comet's fleeting green glow serves as a reminder that even brief cosmic encounters can leave a lasting impact on our understanding of the universe.